So we begin with a new enthusiasm, knowing that the board exam have been cancelled, and now officially you guys can be called class 11 finally. So congratulations. So from now on, you have to take things a little bit seriously because there is no other way out. You are now sure to get promoted in class 11 and you will definitely continue as it is. So we completed two classes on the chapter linear inequalities and we start off with the third one. So in the first two classes we already have done the introduction of whatever we have done so far in our previous classes, and in the second class we talked about simultaneous inequalities. Now in the third class we will be talking about graphical solution of linear inequalities involving two variables. So till now we have worked on one variable, now we will be working with two variables. So now let us see how it works. So from your class 10 knowledge, you already know, class 10 coordinate geometry knowledge, you already know that any linear equation in two variable represents a straight line on the coordinate axis. Say you take x plus y equals to 1 or 2x plus 3y equals to 5, whatever if you take, doesn't matter, it will always represent a straight line. So any equation of the form ax plus by equals to c will definitely represent a straight line. So now also the solution of a linear equation gives you a point on the straight line. So given any solution, I know that solution will lie on the straight line, and also at the same point of time a straight line is an infinite thing, so definitely there are infinitely many solutions. So all the solutions are exactly the points on the straight line. So now if I replace this equal to sign by any of the inequality signs, say I replace it by greater than, or by greater equals to, or by less than, or by less equals to. So if I replace the equal to sign by any of this inequality sign, so let us see what happens. So now for this we will be just shifting our focus a little bit off the PowerPoint presentation and let us come over here. Now this is a very useful tool. You can try using it on your computer if you have. This is desmos.com, which is a very good online software for doing graphic computing. So you can draw your graphs from here. So what you can do, so let me take any straight line, say 2x plus 5y equals to 10. So you see this equation represents a straight line, and this is how the straight line looks like. So now if I change the equal to sign by an inequality sign, so let me just change it by inequality sign. So let us see what happens. So let me just replace this by say less equals to. So I can see what is happening here. It is not only representing the straight line but also the area underneath. So what does that mean? It means that this inequation, let me just change the color once. Yep. So this inequation is actually representing this area. Now we have to understand how does that happen. So let us see why this inequation is representing this. So now in place of x, let us put x is equals to 0 and y is equals to 0. So if I put x equals to 0, y equals to 0, this whole right hand side becomes 0. Now once this right hand side becomes 0, 0 less equals to 10 is a valid statement. Obviously 0 is less equals to 10. So that means what? The point origin here, this point origin, this point here origin, this satisfies the inequation. Are we getting the point? By putting 0 and 0 in place of x and y, I can see that it satisfies the inequation. So therefore 0 comma 0 is also a solution of this inequation. I hope this is clear to you. Then if I take, for the matter of fact, any point here, any point here, any point, doesn't matter, I will see that they all satisfy the given inequality. So therefore, the inequality represents not only this straight line, but also the area underneath it. Now, how to understand which area does it represent? It could have represented this area also, but why I am sure that it is representing this area? Because the fact that I have put the value of origin into the inequality and I have checked that the value satisfies, so I know that whichever side it satisfies, it is going to represent that area itself. Fine. So it is representing this whole area, right? Now this area is actually called, hold on, this area is actually called an open, not open, sorry, this area is actually called a half plane. This area is actually called a half plane. Now in this case it is called a closed half plane. Why closed? Because I have a less than equal to type inequality. If there would have been greater than equal to type inequality as well, it would have been still a closed half plane. What does this closed means? Closed means it includes the line. If it wouldn't have included the line, then it would have been called a open half plane. Now why it is a half plane? Half because the straight line divides the whole coordinate axis into two halves. This is one half, this is another half, and it linear inequation represents either of the two half, any one of the half. So therefore that is the reason why we call these as a half plane. So now let us check what happens when I replace the inequality as a greater than or less than type inequality. So let us try doing so. So let me just replace this by less than type. So the moment I replaced it by less than type, see what happened. The straight line became dotted. So the dotted means we are considering this whole area. But definitely not the straight line. We are excluding the straight line. So therefore this is actually representing a open half plane. Fine. I hope this idea is clear. So from now on, keep this in mind that any inequality represents a half plane. Now depending on the type of inequality, the half plane will be open or closed. If it is a greater than type or less than type, it will be always open. If it is a greater than equal to or less than equal to, it will be always closed. By open, we mean we are excluding the straight line. By close, we mean we include the straight line. Now, when you are trying to draw this on your graph paper, how to draw this? So let us see how to draw this. First, whatever the inequality is given, forget the inequality, First, draw the straight line considering it as an equality. So if you are given 2x plus 5y less than equals to 10 or greater than equals to 10, forget the greater than or less than sign. First, draw the straight line considering it as an equality, because I know that any linear equation will represent a straight line. Fine. Next, my job will be to put the value of x and y as 0. I will be putting the value of x and y as 0. If it satisfies the inequality, then consider the side of the plane where the origin is. If it does not satisfy the inequality, consider the opposite side. So for example, if I replace this equality by greater equals to, see, it is representing the other side of the plane. It is representing this half plane. Why? Because see, if I put 0 and 0 in place of x and y, 0 greater equals to 10 is not satisfying, because 0 is definitely not greater equals to 10. So therefore, I cannot take the side where origin is, but I have to take the other side. So I hope this idea is clear. Now, obviously, in your case, you need not go on shading it completely. You can just put some marks there, just like this. You can put marks like this, and that will be more than enough. You don't have to be too much pedantic trying to shade it like as if you are doing a sketch. Not required. Just a few marks is more than enough to make you understand or make people understand that this is the area you are talking about. So now let us try solving few problems. Now obviously I'm going to take problems from the exercise, so let me take a problem from the exercise here. So let me take this problem here. Okay, so now I have exercise 7.3. Let us take any problem whichever I want, because I'm going to just type it down and it will be showing, so it doesn't matter. So let me take this question number 7, y plus 8 greater equals to 2x. So let me take this one, y plus 8 greater equals to 2x. Let us try plotting it. Now I will be plotting it exactly the way it should be plotted in your graph paper. So y plus 8 greater equals to 2x. Let me first write the equation here. So it will be y plus 8 equals to 2x. Let me first draw the straight line. So this is how the straight line looks like. Let me just zoom out a little bit. Yes, this is what the straight line looks like. Right? Now my job will be to put the value of x and y to be 0 in place of the inequality, and I have to check if it satisfies or not. So if I put y equals to 0, 0 plus 8 is 8, and 2 into 0 is 0. So 8 greater than equals to 0 is a true thing, so it satisfies. So therefore I am going to take this side of the plane. You see, if I put x equals to 0 and y equals to 0, definitely it satisfies. So therefore y plus 8 greater equals to 2x will be this side of the graph, right? So let me just check if it happens or not. So let me replace this equal to by greater equals to, and yes, you see it is representing the side where origin is. So I think the idea is pretty clear how to draw a linear inequality on a graph paper. Now, once we have done this, let us take examples of simultaneous linear inequalities, means more than one linear inequalities, and let us try solving it. So let us go back to the exercise. From here, let us move to the next exercise, that is exercise 7.4. Let us take the first example itself. So first example is this one, 3x plus 2y greater than 5 and y greater than 2. So 3x plus 2y greater than 5, let me just write it here. 3x plus 2y greater than 5. Three x plus 2y greater than 5. So this is exactly the area represented by this. Now obviously, why the dotted line? Because we are excluding the line 3x plus 2y equals to 5. Now let us draw the next one, that is y greater than 2. So this is exactly the second one. So now let us understand how the second one comes. So let me just block this. Let me just block this. See, this is the second one. Hold on. Yeah. So y equals to 2 is this line. Y equals to 2 is this line. Now obviously if I replace y by 0, 0 greater than 2 does not satisfy. So I am not going to take the origin side, but I am going to take the other side. So I am going to take this side, right? So this is how y greater than 2 is represented. So now let us understand how the solution of two simultaneous linear inequality works. See here, three x plus 2y greater than 5 is represented by this area, this whole area, and y greater than 2 is represented by this area, right? Now obviously just remember, when we tried solving simultaneous equations, what we tried to do, we tried to find that common solution which satisfies both the equation. So here also I am going to try to do the same thing. I am going to try to find that common area which is satisfied by both the inequalities. So I can see very clearly that this whole portion is the common area to both the inequalities, and you can see how the overlapping of the color is happening here. So from there also you can understand this is blue, this is red, and this is the common area which is in a different shade. So therefore this is my answer. So when I'm going to draw it in our graph paper, so I'm just doing it here. So I will be drawing it something like this. If this is my graph paper, this is the line represented by y greater than 2, and this is the line represented by the other inequality. So I will be shading only the portion which is common. I am not going to shade any other portion. So just shade the portion which is common. And to represent the areas which each and every single inequality is representing, just put an arrow on any of the side. Just put an arrow. So this arrow will represent which side of the plane it is representing, and only shade the portion which is the common portion. So let us take another example and let us solve, so we will be able to understand. So let us take another one. Say randomly speaking anyone. So let us take question number 4. So question number 4 here, 2x plus 3y less than 12, x greater equals to 2, y greater equals to 1. So 2x plus 3y less than 12. Let me do that first. So 2x plus 3y less than 12. So this is the graph represented. The next one is x greater equals to 2, y greater equals to 1. So y greater equals to 1. So let me do that first, and then x greater equals to 2. Right? So we already have these 3 inequalities. Now let me go one by one. So let us take the first one. So let me block all the other. Let me block the second one, let me block the third one. So let me understand, this is the first area. Fine. Then this is the second area, y greater equals to 1. Let me zoom out a little bit. Okay, this is the second area now, and this is the third area. Fine, all clear. Okay, so now let me start overlapping. So let me overlap this. So now from here I can see that this is the common portion for the first two, this two, whichever the two I have shown here. This is the common area. Now let me unhide the third one also. So now after unhiding the third one, I can see this, that it is just understand the direction in which it is representing. This is the direction of this one, this is the direction of this one, and this is the direction of the third one. So combining all the three, I can see that the common portion is this one, this portion, this small portion, this is the portion. So now if it is a bounded area, you can shade it completely, so that really doesn't matter how much you are shading. So this small triangle that you can see is the solution to all this three system of equation. So when you are trying to draw it in your graph paper, you are going to draw it something like this. So if this is my coordinate axis, this is the first equation. Obviously, as it is a less than type inequality, I have to draw it using dotted lines. If it is a greater than equals to or less than equals to type, then I will draw it using solid lines. Now y greater than equals to 1, it is a line parallel to x-axis, something like this it goes, and x greater equals to 2, it is a line goes something like this, So what I'm going to do, I will be just marking them using the arrow, which side they represent, and I'm going to draw only that, I'm going to shade only that portion which is represented by the three inequalities. Fine. So try not to overshade the whole graph, because if you do so, then it will become too clumsy. Just shade only the common portion which is represented by the three inequalities. Clear? Let us take another problem. Let us take more equations so that it looks a little bit complex. Okay, say let me take question number say question number 9 for the matter of fact. How many equations are there? There are 1 2 3 4 4 inequations there. So first one is x plus 2y greater equals to 2. So let me just cancel out all of these. Okay, so x plus 2y greater equals to 2, this is the first one. Next one is x minus y less equals to 3. So next one is x minus y less equals to 3. Then the next one is y less equals to 4x greater equals to 0. So y less equals to 4 and x greater equals to 0. Fine. So there are way too lot of things going on here. So let us just simplify the whole thing one by one. So let me just okay, let me start off. Now let us start off with the first one by so first one is representing this black area, so it is representing this direction. Just remember the direction it is representing. The directions are important. Next, let us try understanding the second one. The second one is representing this area, right? Now let us understand the third one. The third one is representing this area, that is starting from 4 downwards, and x greater equals to 0 is obviously starting from 0 right side. So now let us unhide all the 4 inequalities, all the 4 regions, and see which is the common region. So after unhiding this 2, I can see this is the common region. So let me just mark it first. So this is the common region after unhiding the 2 side, 2 inequation. Let us unhide the third one. After unhiding the third one, I can see this is the common area. This is my common area, this whole thing. Next, let me unhide the fourth one. So after unhiding the fourth one, I can see that this portion, this is the common shaded area, right? So what we are going to do while solving this, we are going to just mark using an arrow. So let me just zoom out a little bit. Okay, let me not zoom out. I can do it from here itself. So this is representing this side. This one is representing the other side. This is representing this side, and x greater than 0 is representing this side. So just mark all the region by the arrows, then understand what is the common area and shade only the common area. So that will be more than enough. Fine. So that's it. So this is our class. Hope you have understood. Now obviously from this chapter, or this part of the chapter, graphical solution of linear inequalities, you are sure to get one question in your in your final exam. So therefore ensure you practice it at least 3 or 4 questions. So hardly there are 10 or 12 questions. So just practice it, check it for yourself if you are getting the answer or not. I will send the exercise as well as the answer page of this 2 exercises for you to check. And if you have already got the book, it's very good. Do it from there. And obviously, if you have doubts, you can always clarify. Thank you so much.